Okay, let's start our topic of discussion, units and measurement. So, starting with introduction. Before that, we should know about physical quantities. So, what do we mean by physical quantities? So, anything which can be measured and we can express the laws of nature in terms of those things. We call them physical quantities. For example, time, we can measure time. For example, distance, of course, we can measure distance. For example, speed. So these things are physical quantities. These are measurable quantities, and we can express some natural phenomena in terms of these quantities. For example, let's take this scenario. Suppose a body is moving from point A to point B, and the distance between these 2 points, let's say it is S, and time taken by this body to move from A to B is T. So we can say speed equals to distance by time. So this way we are representing a natural phenomenon which is occurring here in terms of these things, and these things are measurable. So we call them physical quantities. Now, what do we mean by measurement? If we are saying that, okay, we are measuring this quantity, what do we mean exactly? So measurement is an act of comparison. If we go for measurement, what we do actually, we compare with some standard quantity. Let's say we have measured the distance between these 2 points, A and B, and this distance came up something 10 meters. Let's say. So what? How we have measured this? We have just compared with some standard length. Let's say this length is 1 meter. So we have compared with this standard length, and if we just comparing the length of this path AB, and it turns out to be 10 times of this standard chosen length. So we say that, okay, distance between these 2 points, that is length of this path, is 10 meters. So this is measurement, means act of comparison. Now what we see here, a physical quantity, distance, is being expressed in terms of a numerical value and unit. So this is with all physical quantities. We can express in general, if we want to write in general, if we want to express a physical quantity x, we can express it in terms of a numeric figure and unit. Here 10 is the numeric figure and meter is the unit of this measurement. So now what do we mean by unit? So unit is standard length here in this case. If you are measuring something different, if we are measuring mass, so unit will be something different, but that amount will be a standard. That amount we used to take as a standard to compare other given amounts and to express the measurement. Okay, let's take another example of measurement. So, okay, let's say we have a box and we want to measure its mass. So, mass of the box, and we have some standard mass here, and we call this mass to be 1 kg. And we started comparing these two masses. So, one box has mass equal to, let's say, 5 such standard boxes. So we can say, okay, mass of this box is 5 kg. This is a kind of comparison. We have compared the mass of this box with some standard value, and then we are expressing the physical quantity mass. Look, again here, this physical quantity mass is expressed in the form of some numeric figure and unit. So this way, in general, a physical quantity can be expressed. Now, if the physical quantity is a kind of vector quantity, then there will be some direction here. But for now, let's take magnitudes only. One more thing, if we are expressing a physical quantity x by nu, and in one kind of system, and in another system, this x has been expressed by some another numeric value and some another unit. So no matter in which type of system we are expressing this physical quantity, these two should be equal. Just keep this point because in case of unit conversion, we are going to use this concept. Now, a set of units, a standard units, you can say, a set of standard units we call system of units. And here, these are three common international system of units which are widely being used. One is MKS, and in MKS system, length is measured in terms of meter, and mass is measured in terms of kilogram, and time is measured in terms of second. In CGS system, another system of unit, length is measured in terms of centimeter and mass in terms of gram, and this in second. Next is FPS system, we call it British system also. So in this system, length is measured in terms of foot, we generally write it FT, and mass is measured in terms of pound, this is LB, sometimes you will get LBS, and time is measured in terms of second. So these are most commonly used international systems of units. Now, out of this, all, this MK system is upgraded, and then we have now a international standard, which we call SI system of units. So let's take a look about that. SI system of units. It was developed by Bureau, the International Bureau of Weights and Measures, and in 1971, and again revised in 2018 in a general conference on weights and measures. So this SI system is a kind of improved version of this MKS system, and now this is widely being used. This system comprises seven fundamental units, and along with this, two supplementary units are there. These seven fundamental units or base units are for fundamental quantities or base quantities, and all other different units for different quantities are derived from these fundamental quantities. So here we have units, two types of units. One is fundamental, another is derived. For example, if we are going back to this example, okay, here. So look, if we have this distance, which is a kind of length, and this is time. So distance and time, these two are base quantities. And with the help of these two quantities, we have derived the new quantity. So we can say if we are measuring the distance in terms of meter, and if we are measuring time in terms of second, here we have a unit of speed, unit of speed, and it is meter per second. So the unit of speed is not fundamental unit, but it is being derived with the help of the unit of distance and the unit of time. So this way we can classify all these quantities in fundamental quantities and derived quantities. So we have in our international standard system seven fundamental quantities, and other quantities are derived from these fundamental quantities, and along with seven there are two supplementary also. So here we have a table indicating all these base units or fundamental units for fundamental quantities. So one is length, and it has unit meter, and symbol is m. So in this line we have in this column we have base quantities. In this column we have name for units, and here we have symbol. And one thing should be very clear here. Look, while writing the name of a unit, we have to be careful about this first letter, because look, here we are expressing electric current in terms of ampere. So if we are writing ampere in this way, actually this would be the name of scientist ampere. So we have to be careful about this. While writing the name of unit, we have to start with lowercase letter, a small letter, otherwise it will indicate the name of the scientist in most cases. Of course, second is not any name for a scientist, but yeah, in most cases, like unit of force, we call Newton. So if we express unit of force, and we have to choose this way. Otherwise, if you are expressing this Newton with capital letter, we are expressing the name of the scientist. So this should be taken care of. Okay, so here we have all these base quantities: length, mass, time, electric current, thermodynamic temperature, amount of substance, luminous intensity, and we have symbols here for their units. And length expressed in terms of meter, then mass in kg, time in second, electric current in ampere, thermodynamic temperature in Kelvin, and amount of substance in mole. And then we have luminous intensity in candela. Later, while studying further, we will discuss all these things one by one. For now, we have just introduced these things. Now, coming to supplementary units. So, these two units are for angles, one for plane angle and another for solid angle. So, let's start with this plane angle. If we have let's say we have a circle here, and okay, let me draw it first. So, this circle, okay, so this circle, and it has radius r, and let's take a small arc of length ds. So the angle subtended by this arc ds at the center, let's say this angle is d theta. So we have definition here: d theta will be ds by r, and this thing will be represented in terms of radian, and radian is the unit of plane angle. In short, RAD. In the same way, we have another supplementary unit which we call solid angle. And for solid angle, let's consider this structure to be a sphere. So if this structure is a sphere, we can take small area here on its surface, and the angle subtended by this area, let's say this is the center, and the angle subtended by this area at the center, this will be a kind of conical. We can see it. It is not a plane angle. It should be taken care that it is not a plane angle. Rather, it is like conical. For example, let's say this way. This is the angle there. So this angle is solid angle. And if this area is something dA and radius again r, so we can write this angle here. I'm representing the same thing here. If we are representing this thing by d omega, then we have d omega equals to dA by r square. And this thing we represent in terms of steradian. Just a minute. Okay. And symbol for this is SR, smallest small r. Be careful about that. This is both lowercase. So this is supplementary. These are supplementary units. One is for plane angle, another is for solid angle. And I hope you can figure out what do we mean by solid angle. Okay. Coming to next point. There are many examples of non-SI units which are common to use. So, for example, minute. This is not a common unit for time, but this is a common unit for time, but not a SI unit. And we can say year. We used to use these things. Liter, of course, carat. Okay, 1 carat is 0.2 gram. Just remember this thing. And yes, one more thing here. This carat is different from the carat we used to talk about gold jewelries. Suppose you have heard about this thing that 18 karat gold or maybe 22 karat gold. So this carat is different from this. This carat is used for gemstones. If you are talking about a 10 carat diamond, it means a single piece of diamond weighing 2 gram. So, but this carat for gold or yeah, making gold jewelries, this carat is different. This carat represents how much gold has been used to make that jewelry. For example, let's take. an example to make it more clear so that there won't be any confusion between these two carats. So if you are saying that, okay, 22 carat gold jewelry, it means that out of 24 parts, out of 24 parts, 22 parts is gold, and other two parts maybe silver or copper, other thing. In the same way, if we are talking about 18 carat gold jewelry, it means out of 24 parts, 18 parts is made up of gold. So it means if we are taking gold jewelry of 24 grams, 18 grams gold is present there, and remaining 6 grams maybe some other elements. Okay, before moving ahead, let's discuss one more important thing here. These are base quantities, and how do we define them? That is, if we are saying that, okay, this is 1 second, so how do we define that this amount of time should be 1 second, or this amount of mass should be 1 kg? So there should be some standard approach to define them, and yes, there is. But it has a very long history. Time to time, it has been updated. The way we define these things has been updated over time. And now there is a very refined and latest way to define these things. For example, if we have to define this time 1 second, so scientists used to take an atomic activity in cesium atom, where there is some kind of, let's say, there is some kind of atomic activity there, and that atomic activity takes place, and the time in which this much atomic activity takes place, scientists refer this thing, the time taken, to, and there is nothing to be bothered about these things right now. What activity is going there? As we go ahead, as we study further about atoms and nuclei, we will come to know that what activity we are talking about here. So, for a moment, let's take there is some kind of atomic activity happening in cesium atom, and the frequency of that activity is this much has been taken. So, the time in which this much activity has been completed means this much vibrations are there. We call that time 1 second. And based on this thing, we have the most precise clock till the date, and that is we used to call atomic clock. So this way, in this way, we define 1 second. And okay, if you are taking 1 second, now we can define length also. And to define 1 meter of length, we have to use one more quantity here, which is speed of electromagnetic wave in vacuum. So let's say speed of light in vacuum. That is c. And to be precise, this speed is something 299,792,458 meter per second. So this is speed of electromagnetic wave in vacuum, which has been decided earlier. And now this thing is being used to, along with this definition for 1 second, to define 1 meter. So, okay, for now, take it as it is. Later on, we will discuss about these things as the course goes on, and then these things will be more clear. But for an idea, take these things. So, and of course, there are some more fundamental constants, means kind of natural constants are there, like Planck constant, like electric permittivity of free space, and I hope you all know this quantity, that is charge, unit charge on electron, or unit means not in terms of SI, but naturally unit charge on electrons or protons. So these things, these natural constants, and this is gravitational constant, these natural constants are being used to define all these fundamental quantities. And the reason behind taking these natural constants is these constants are mostly unaffected in space and time. So, and of course, this should be a property of unit. that it should not be affected by change in space or change in time, so that it will remain relevant no matter when we are using these quantities, where we are using these quantities. They should not be affected by external factors as long as we are sticking to the definition. Okay, that's all for this video. And in next, we are going to study about the error. While doing measurement, we may encounter some errors, and not may, but yeah, we encounter some errors. So in next topic, we are going to discuss about these errors, and we will try to rectify them. We will try to get the idea about how those errors can be eliminated or their impact can be minimized. So see you.